This lesson is on how to find the constant of proportionality. Constant proportionality is a constant multiple that relates proportional quantities x and y. It is the value of y divided by x, which, remember, means we would have a proportional relationship, and it is represented by k. So our constant proportionality is k is equal to y divided by x. So it would have to be the same for each ratio in the problem in order to have a proportional relationship. Just a review of our dependent versus independent variables. The dependent variable changes based on the independent variable. And in math, what we're going to be working on, the dependent variable is going to be your y value. The independent variable is able to change on its own and will be represented by the x. So just to remember, y depends on the x value. So we're writing the equation of a proportional relationship. Once we have our constant proportionality k, we can write an equation in the form y equals kx. The first problem, a florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. That means that this relationship is going to be proportional because the unit cost is the same. We want to write an equation. So since we're writing an equation, it's going to be in the form of y equals kx to represent the relationship between the number of roses x and the total cost y. Now they told us what y and x are, but even if they didn't, we would know that the roses depends on the cost. So that's why the roses is the y, and the roses is the x, and the cost is the y. So I'm going to first find my constant proportionality by doing y divided by x. My y is the cost, so that's 35.4, and the number of roses is 12, because a dozen means 12. 35.4 divided by 12 is 2.95. So since I have my constant proportionality is 2.95, I can write my equation y equals 2.95x. Now the point of the equation is that we can use this now to determine the cost of any number of roses or the number of roses based on the cost. We want to know how much 18 roses would cost. The 18 roses, that's my x value. So I would have y equals 2.95 times 18. 2.95 times 18 is 53.1. So we would know that 18 roses would cost $53.10. The second problem, we have two different balloons. One that is released 5 feet above the ground, and one that is released at ground level. They both rise at a constant rate. Which of the following tables can be represented by the equation y equals kx? So if we want it to be represented by y equals kx, that means we need to have a proportional relationship. So in order to have a proportional relationship, we have to divide y by x and get the same ratio for each part of our table. Now the height is the y because it depends on the time. So for balloon A, 9 divided by 1 is 9. 13 divided by 2 is 6.5. Now, since I got two different numbers, I don't need to continue. I just know that balloon A would be not proportional. Now for balloon B, 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. And since I got the same number each time, we could say that balloon B is proportional, so it can be represented by the equation y equals 4x, because 4 is my constant of proportionality. Determine which equation represents a proportional relationship. If we want the equation of a proportional relationship, it has to be in the form y equals kx. If it does, identify the constant proportionality. So this first one, y equals negative 0.5x minus 2. Since we have this minus 2 here, this relationship or this equation would not be proportional. Because in order for it to be proportional, remember, it's just a number times the x. And that number is our constant of proportionality. For the second one, we have y equals 1000x. That would be a proportional relationship because it's just a number times x. And the k value, or my constant of proportionality, would be 1000. The third one, y equals x plus 1. Since we have this plus 1 here, it's not just a number or a constant times x, it's the plus 1. So this equation would not be proportional. And the last one, y equals x. It looks like there's no constant proportionality, but we have to remember, when we just have y equals x, there's an imaginary 1 there. So this last one would be proportional, and our k value, or our constant, would be equal to 1.